This example also comes out of 1.3, geometric sequences. We looked at 3 different geometric sequences in the intro examples, showing what their common ratios are. Now, if we were asked to find the general term of a geometric sequence, general term, again, is on your formula sheet, and it looks like this. It says Tn is equal to T1 multiplied by r to the n minus 1. So as long as you know the first term and you know the common ratio, you can write the formula right away. So for example, for this guy, it was 2, 6, 18. We have the first term is 3. The common ratio, or sorry, the first term is 2. The common ratio is 3. And so my general term is 2 times 3 to the n minus 1. So if somebody asked me for term 10 in this sequence, I could let n be 10 and figure out, oh, what's 3 to the 10 minus 1, and then multiply that by 2. And I could skip, rather than listing out 10 numbers in the sequence, I could skip right to the 10th number in the sequence. So the same would be true here. This is also geometric. We said the common ratio of it was 1/2. So we have the first term, we have the common ratio. So the general term is first term multiplied by common ratio to the n minus 1. So again, if somebody asks me even for the 50th term in this sequence, I don't need to write out 50 terms. I just let n be 50. 50 minus 1 is 49. 1/2 to the exponent 49 gives me some tiny, tiny number. Multiply that by 100, and you have the 50th term of the sequence. The third last example here in this one, another geometric sequence. This one's strange because it had a negative common ratio. Makes no difference for what we're doing here. Tn equals the first term multiplied by the common ratio to the n minus 1. And so again, same uses. If you're asked to find some term way down the sequence, you could find it directly using the general term rather than listing out term after term after term, especially if n is a big number.